All right, let's get some quick, easy applications of polynomials. There's some more fun things that you can do with these ones. We're going to stay pretty simple to be kind of more aligned with the book today. And we're just going to be modeling things as polynomials, all right? Then once you model things like polynomials, you can actually start solving and using technology, using calculus. We're not going to be using calculus because this is, of course, not a calculus class. But we're just going to be modeling, get some practice writing equations for real world things. Simple versions. Real world. A lot of times real world applications are much more complicated and much more messy, but this is going to be like training. So we have an oil slick. This oil slick is expanding as a circle. The radius of the circle is increasing at a rate of 30 meters per day. Express the area of the circle as a function of t, the number of days elapsed. Okay, so let's say that, let's just look at this, right? What's happening? I have an oil slick. That's not good. It's increasing by 30 meters per day. That's not good. How's the area changing over time? So what is the area of a circle? Area of a circle is pi times the radius squared. That's important information that we should write down. What's going on here? After 0 days, after 0 days, there is no circle. After 1 day, there's a circle with radius 30 meters. That is too small. Well, after 2 days, the radius is increasing by 30 meters every day. So after 2 days, the radius is twice as big. After 3 days, the radius increases by another 30 meters, etc. So how is the radius changing over time? Because what I really, really want, is I want the area as a function of time. So it's going to be pi times the radius squared. But this radius is also a function of time, right? This is t. This is our radius as a function of time, r of t. So what's the pattern here? 0, radius 0. 1, radius 30. 2, radius 60. 3, radius 90. What's happening? Well, the radius is just 30 meters for every day that passes. 30t. I don't know why I'm doing this entire solution in red, but that's our radius. There we go. And we can simplify a little bit. Our area function is going to be 30 squared, that's 900, times pi, times t squared. This tells us the area of this oil slick after however many days. And you could check your answer by plugging in some values here. At 0 days, yep, area is 0. After 1 day, area is going to be 900 pi. You should be able to use the area formula here to also get 900 pi meters squared, and so on. All right. T is the number of days elapsed. And then A is area in meters squared. And that's example 4. Example 5 says we're looking at a rectangle. Let's approach this problem by writing down things as we come across them. We have a rectangle. Let's draw a picture. The rectangle length of 10 inches and a width of 6 inches. Good, nice little picture. If the length is increased by x inches, so increasing that length by x, and the width is also getting increased by twice that amount. Okay. So the width is also getting increased. Now we have this big rectangle. Again, how much is this getting increased by? This width is getting increased by 2x. Express the area of the rectangle as a function of x. So again, area is length times width. So what's the length and the width of the blue rectangle? Well, we're going to write it with function notation. Area is now a function of x. This is a of x right here, function notation, just like f of x. Well, is the length, it used to be 10, it got increased by x. The length is just 10 plus x times the width, it used to be 6, it got increased by 2x. This is our new area function. And I'll accept it in this form, or if you FOIL it out, you should get 2x squared plus 26x plus 60, I believe. All right, you can FOIL this out. 60, 20x, this makes it 26x, and 2x squared. Good. These are both good ways of writing your answer. And again, x is the length of the increase, and area is in inches squared. You could write that down. That would be great. All right, there we go. That's the applications video. Enjoy.